Hello and welcome to House of Math. In today's video, we are not going to be covering a new topic. We are going to be covering a new skill known as rationalization, which is going to allow us to more easily cover the upcoming topics. And so, what is rationalization? In particular, what does it mean to rationalize the denominator or the numerator? Well, rationalizing the denominator or the numerator, it does work the same way, is the process where you change where the radical is located to change what the expression looks like. Okay, so we are not actually changing the value of the expression, we are just rewriting it. We are changing the way it looks. And so to rationalize the denominator or the numerator, we need to get all of the square roots out of the denominator or the numerator, depending on what it is that we are rationalizing, okay? So let's take a look here at our first example. Let's rationalize the denominator of 3 over the square root of 3. And so what we want to do is that we want to get rid of this square root of 3, right? This is what we had just talked about. And so in order to do that, what we are going to do is that we are going to multiply and divide by the same amount. In this case, we are going to multiply and divide by the square root of 3. And why do we do that? Well, because this is equal to 1. So we are not changing the value of our expression at all, right? And when we do that, we are going to have 3 root 3 in the numerator, and then square root of 3 times the square root of 3. And we can just simply rewrite this as 3 root 3 square root of 3 squared, right? The square root and the square cancel out, and this is going to leave us with 3 square root of 3 over 3, which of course we can simplify further to the square root of 3. Okay, so this is basically the gist behind rationalizing a denominator. Let's take a look at another quick example here. Here we have 10 over 2 root 5. And the first thing that I'm going to do here is that I am going to simplify this expression, because immediately 10 is equal to 2 times 5, right? So I'm just going to get rid of that factor of 2 that I have in both the numerator and the denominator. And so this is going to give me the expression 5 over root 5, which I might recognize as being very similar to the expression that we have just worked on, right? And so we might already be able to say what this expression is going to be once we rationalize it, right? Some of you might already be guessing that, yes, we are going to end up with square root of 5, and yes, we are, but let's see how we get there. Okay, so this is the starting expression. And so again, we want to rationalize it. To do that, we are going to multiply and divide by the same amount. In this case, I have a square root of 5 in the denominator, so that's what I'm going to multiply and divide by. Okay. So when I do that, I'm going to have 5 root 5. And of course, the square root of 5 times the square root of 5 is going to become a 5. I cancel out the 5s. And I get just the square root of 5. In this example, I decided to do it in a few less steps, okay? Because a lot of these steps are a bit redundant. We do not need to show them every single time, but it is the same process, just slightly more condensed. I wanted to show you both versions of the problem solving here, okay? Okay. So this is basically level 1 of rationalizing a denominator. But now, what if our denominator is not just one term? What do we do then? So when the denominator is a binomial, like this one here on the screen, 3 over the square root of 2 minus the square root of 3, it is a binomial because it has 2 terms, right? Then things do get a bit more complicated. Still doable, just a little bit more complicated. So let's see what works better here. We're going to try a couple of different approaches. So let's try by multiplying and dividing by the denominator, because that's what we did in the previous example, right? We were able to just multiply and divide by the denominator itself. And let's see if that works this time. Here again, I am not changing the expression at all because multiplying and dividing by the same thing is the same as multiplying by 1. So this is not going to affect the value of the expression. But now let's see what we get. So from here, I am going to have 3 times the square root of 2 minus the square root of 3 in the numerator, and in the denominator, I'm going to have the square root of 2 minus the square root of 3, all of that squared, okay? We can certainly simplify this expression, right? And so we are going to have 3 square root of 2 minus 3 square root of 3. And now let's expand the binomial here in the denominator to get square root of 2 squared, which is just 2, minus 2 times the square root of 2 times the square root of 3, or just simply the square root of 6, right? And then plus the square root of 3 squared, which is simply equal to 3. And we can simplify this further. The numerator stays the same, we cannot simplify it anymore, but we are going to have 3 square root of 2 minus 3 square root of 3. And in the denominator, we can combine the 2 with the 3 to get 5 minus 2 square root of 2 square root of 3. And so now we cannot really do much more here. We got to leave it like this. So is this what we wanted? Have we rationalized the denominator here? Well, no, we still have radicals in the denominator, right? So this expression is certainly not rationalized. So clearly this method does not work. Multiplying and dividing by the denominator does not work. Let's try a different method. Okay, so what if we break up the binomial and we multiply and divide the original expression by each of the terms in the binomial? Let's see if this is going to work now. Okay, so again, I'm not changing the value of the expression at all because I am just multiplying by 1 twice, right? Here I'm multiplying and dividing by the square root of 2, which is the same as multiplying by 1. And then I'm going to be multiplying and dividing by the square root of 3, which is the same as multiplying by 1 as well. So again, I'm not using any operations that are going to affect the value of the expression. I am just trying to change what the expression looks like, but not its value. Okay, and so let's do this. Putting it all together, for our numerator, we are going to have 3 square root of 2 square root of 3, right? We're getting all of that multiplied. And then for the denominator, we are going to have the square root of 2 minus the square root of 3 times the square root of 2 and times the square root of 3. Okay. And so here, well, what are we going to get? Of course, we could just cancel everything out, but there's no sense in doing that because we're just going to end up with the original expression. So let's try and expand this. All right, so we're going to leave the numerator as is because there's nothing that we can expand in the numerator. And let's expand the denominator. Okay, so I'm just going to go one term at a time. I'm going to start by distributing the square root of 2. So square root of 2 times the square root of 2. This is going to be equal to 2. And then square root of 2 times negative square root of 3. This is going to be equal to negative square root of 2 times square root of 3. Okay? And now all of this we still have to multiply by the square root of 3 as well. Okay? So let's do our second distribution here now. So we're going to start by distributing the square root of 3 times 2. And this is going to give us, here we're going to leave the numerator the same. And now distributing the denominator once again, we are going to have 2 times the square root of 3. And now minus the square root of 2 times the square root of 3 times the square root of 3. So now here, the square root of 3 times the square root of 3, the square roots are going to cancel, and we are just going to be left with 3 times the square root of 2. And so this is our final expression. We have 3 times the square root of 2 times the square root of 3 over 2 square root of 3 minus 3 square root of 2. So again, I ask the same question. Is this expression rationalized? Again, no, it is not, because we have radicals in the denominator still. So also not rationalized. So it seems like we still have not found the right method. Okay, so we have tried multiplying and dividing by the denominator. We have tried breaking the denominator into 2 parts and multiplying and dividing by each part. So what is left to do? What's something else that we can try? Well, what if we try multiplying by the conjugate of the denominator? Okay, and so by conjugate, what I mean is the same binomial, but with the opposite sign. So in our case here, okay, we are going to have, if we have a binomial, okay, so if we have a binomial, A plus B, then the conjugate is going to be A minus B. Okay, so we are changing the sign in between the 2 terms. Okay, so A plus B becomes A minus B. In our case, we have the square root of 2 minus the square root of 3, so the conjugate becomes the square root of 2 plus the square root of 3. Okay, so notice how the signs are different. Okay, and again, we are going to multiply both the numerator and the denominator by this amount to ensure that we are not altering the expression, that we are still technically just multiplying by 1. And we of course know that multiplying a number by 1 does not affect the number itself, right? Okay, so let's see if this works. Okay, so here we are going to have in the numerator 3 times the square root of 2 plus the square root of 3. We'll expand that in 1 second. And now for the denominator, we are going to have the square root of 2 minus the square root of 3 times the square root of 2 plus the square root of 3. Okay, let's expand all of this here. So here in the numerator, 3 times the square root of 2, that's going to be 3 square root of 2 plus 3 square root of 3. Just using the distributive property here. Now for the denominator, this is where we're going to have some fun. Okay, So again, using distributive property, we are going to FOIL the expression. And here we are going to do 2 times the square root of 2 times the square root of 2. This is just going to become 2, right? Let's keep going. And now 2, or the square root of 2, times the square root of 3. This is going to become a positive square root of 2, square root of 3. And now we got to do our second term, which is a negative square root of 3. So we're going to do negative square root of 3 times the square root of 2. And I'm just going to write it as negative square root of 2 times square root of 3. And now I'm going to multiply square root of 3, or negative square root of 3, times square root of 3. And of course, the square roots are going to cancel out, and I'm going to end up with a negative 3. And so now here, something really cool happens. Because we are multiplying by the conjugate, we have that once we expand the binomial, that the middle terms have opposite signs. And since they have opposite signs, that means that we can cancel them. And we are going to get 3 square root of 2 plus 3 square root of 3 over 2 minus 3, which of course is equal to 3 square root of 2 plus 3 square root of 3 all over negative 1. And we can simplify this one more time. Of course, it is already rationalized here. We don't have any radicals in the denominator, but we can go one step further to make sure that it's simplified as much as we can. And we're just going to bring that negative sign over to the numerator. And we're going to have negative 3, factoring it out, square root of 2 plus square root of 3. And this is certainly been rationalized. Okay. So here, this expression is finally rationalized. There we go. Okay, so clearly the conjugate works. Let's check it one more time with a slightly different expression. Okay, so let's try this one now. 5 over 2 root 6 plus 3. So again, we want to use the conjugate, right? What is the conjugate of 2 root 6 plus 3? Well, we have our two terms, 2 root 6 and 3. And in order to get the conjugate, we want to change that sign in the middle, right? So the conjugate is going to become 2 root 6 minus 3. That is the only change that we have to do, that we have to make. Okay? And so now with this change, we have our new conjugate. So let's multiply both the numerator and the denominator by this conjugate. So here we are going to start with our original expression, 5 over 2 root 6 plus 3. And now we multiply top and bottom by the conjugate. 2 root 6 minus 3 over 2 root 6 minus 3. And now it is basically the same steps that we did before. We just have to expand and then simplify. So let's do that. For the numerator, we are going to have 5 times 2 root 6 minus 3. And for the denominator, we are going to have 2 root 6 plus 3 times 2 root 6 minus 3. Okay, so now here again, we need to use the distributive property, and we are going to end up with 5 times 2 root 6, right? That is going to bring us here to just going to fix that expression there. There we are, that's where I want you. Okay, so going back to our distributive property, we are going to have 5 times 2 root 6. So 5 times 2 is equal to 10. So 10 root 6. And then 5 times negative 3. That's going to be equal to negative 15 in our numerator. Moving on to the denominator. It is going to be a longer denominator. We have a big expression here that we have to expand. Let's do it step by step. We are going to have 2 root 6 times 2 root 6. Okay, so 2 times 2 is 4, and root 6 times root 6 is just going to be equal to 6. So we're going to technically have 4 times 6 as our first term. And now we are going to do 2 root 6 times negative 3. So I'm actually going to change that sign there to a negative 3 times 2. So that's going to be negative 6 root 6. And now I'm ready to do the second term. So here, positive 3 times 2 root 6. So 3 times 2 is 6. So this is going to be positive 6 root 6. And now finally, we are going to have positive 3 times negative 3, which is going to be equal to negative 9. And now we can see again, through the magic of using the conjugate, our middle terms, which were the issue before, we are able to cancel them out. That negative root 6 and that negative 6 root 6 and that positive 6 root 6, we can cancel them out. And of course, we are going to get 10 root 6 minus 15 all over 4 times 6 is 24. 24 minus 9. This is going to be equal to 10 root 6 minus 15 over 15. And here, of course, now we might notice that it's all terms of 5, right? And so we can factor out a 5 from both the numerator and the denominator. So 5, 2 root 6 minus 3 over 5 times 3. We cancel out those extra 5s that we have just factored out. And this is going to give us our final answer of there we go. So it's going to give us our final answer of 2 root 6 minus 3 over 3. And again, is this expression rationalized now? Yes, it is. Okay. Why? How do we know it's rationalized? Because we do not have any radicals. We do not have any square roots in the denominator. We haven't done any examples for the numerator, but it is the same process. We would also multiply by the conjugate. You can try it with any of the examples that we have done just by flipping the numerator with the denominator, and it would work exactly the same way. I hope this video was helpful, especially as we move on to limits, where we are going to have to rationalize some functions, and I will see you in the next video. Bye!